We'll now discuss the law of sines and how this can be used to solve generic triangles. The law of sines says that sine of angle A over A is equal to sine of angle B over B, which is equal to sine of angle C over C. And ideally, what this means is we have this triangle with sides A, B, and C, and the angles are labeled opposite. So the angle opposite side A is capital A, the angle opposite side B is capital B, and the same thing with C. And this can be used to solve 3 different types of triangles that we will look at. Here we have our first triangle, and this is known as an SAA triangle because we know a side and then the following angle and angle moving around the triangle. Ideally, we know 2 angles and one of the sides that's not in between those 2 angles is the idea. And now we can use this law of sines to solve this triangle. First, we can find our third angle pretty easily, since we know that the sum of the angles of a triangle are always 80 degrees. And knowing this gives us the value of angle C. So we know that angle C here is equal to 65 degrees. And now we can use our sines. So I know that sine of 35 over 6 is going to be equal to sine of 80 over its opposite side, which is B. And then we can just divide and multiply. So we'll start with the fact that sine of 35 divided by 6 gives us 0.096. And then on the right, sine of 80 is 0.984 over B. We can then multiply both sides by B. And solving gives us that side B is equal to approximately 10.3. We also need sine C, or side C. So for that, I know that sine 35 over 6 has to be equal to sine of angle C, which we found to be 65, over C. Once again, sine of 35 over 6 is 0.096. And now we can just deal with sine of 65 on the right, which is 0.906. Multiplying by C gives me C times 0.096 is equal to 0.906. And then we can solve for C. And we get that side C is approximately 9.48. So now I've solved my triangle. These triangles are called ASA for angle side angle because we know 2 angles and the side between them. And we can use the sine rules the same way we did before. This time, we have that C plus 10 plus 30 is equal to 180. So angle C must be equal to 140 degrees. So my triangle here is definitely not drawn to scale, but that's okay. I can now use the fact that sine of 140 over 8 is equal to, and we'll start with side A, so sine of 10 over side A. So now we need to start evaluating this. We'll start with sine of 140 divided by 8, which gives us approximately 0.080. On the right-hand side, the sine of 10 is 0.174. We can then multiply both sides by A and divide. This gives us that A is approximately 2.16. Next, we need side B. So I have sine of 140 over 8 is equal to sine of 30 over B. Sine of 40 over 8 is still 0.080. Sine of 30 is 1/2. We can multiply both sides by b, and then we just need to divide. And this gives us that our side b is approximately 2.22. So now we've solved this triangle.